Section 10.3, Area of Regular Polygons. The center of a regular polygon is equidistant from the vertices. The radius of a regular polygon is the distance from the center to a vertex. The apothem is the perpendicular distance from the center to a side. The apothem is also used in finding the area of the regular polygon, so keep that word in mind. A central angle of a regular polygon has its vertex at the center and is found by taking 360 divided by the number of sides. So question 1 says the figure is a regular pentagon with radii and apothem drawn. What is the measure of each angle? So if we look here, the first angle we have is angle 1. Well, angle 1 is a central angle for this shape. So to find the measure of angle 1, we're just going to go back to this statement here. And we're going to take 360 divided by the number of sides. Well, if it's a pentagon, it has 5 sides. So that angle measure is just 72 degrees. From there, we're then going to look to find the measure of angle 2. Well, angle 2, if we know that this upper angle here is 72, angle 2 is a part of this smaller, what essentially becomes half of that angle, because together that would make 72. So to find the measure of angle 2, we're going to take half of angle 1. So taking 72 divided by 2, and we're going to get 36. And the reason we know that that's half is, if you recall from the previous chapters, these are radii lengths here. So they're congruent. And so this is a perpendicular measurement coming from the vertex of essentially an isosceles triangle. So it's also bisecting the angle up top. All right, so the last thing we need to do here is find the measure of angle 3. Well, the measure of angle 3 is pretty straightforward. If we know that angle 2 is 36, we know we have a right angle here. Well, we could recognize that this makes a very small triangle. So we're going to take 180 minus 90 minus 36, and we're going to get the measure of angle 3 is going to be 54 degrees. And we're done. All right, moving on to the next example. We have a portion of a regular octagon, and they've asked us to find the angles here. Well, angle 1 is also a central angle here, so it's just like the previous example. 360 minus the number of sides, so 8, gives us an angle measure of 45 degrees. So angle 1 is 45. Then we do very similar to the previous step. Find the measure of angle 2. We recognize the same relationship here. It's half of angle 1, so angle 2 is going to be 1/2 of 45, which in this case is 22.5 degrees. And then to find the measure of angle 3, same idea. We have 180 minus the 90 for the right angle we have, minus angle 2, gives us an angle measure for angle 3 equal to 67.5 degrees. All right, so here we're introduced to the area formula for a regular polygon. The area of a regular polygon is equal to 1/2 the apothem times the perimeter. And remember, perimeter is the length of all the sides added up. So first problem we have here is a regular octagon, and we're looking for the area of a regular octagon. So they provide us with this measurement here, which is the apothem. So 14.5 is the apothem. So our area formula is 1/2 apothem times perimeter. Well, to find the perimeter of an octagon, we're going to take the number of sides times the length of each side. Well, 8 times 12, that's going to give us a perimeter of 96. So our area formula equals 1/2 the apothem of 14.5 times 96, which in this case gives us an area of 696 centimeters squared. Question 2, a regular decagon with an apothem of 15 inches and side length of 9.5. So let's go ahead and find the perimeter. Well, a decagon has 10 sides, and every side is 9.5. So the perimeter here is 95 inches. So our area formula becomes 1/2 times the apothem times the perimeter. Well, in this case, the area equals 712.5 inches squared. And then last but not least here, a regular pentagon. Well, pentagon is 5 sides, so perimeter would be 5 times 3.5, which gives us a perimeter equal to 17.5 yards. So our area formula is 1/2 the apothem, 2.4 times 17.5. 17.5, there we go. Then we multiply this out, and our area for this particular shape is 21 yards squared. Sometimes you'll be asked to find the apothem before you're asked to find the area of a regular polygon. So this means you may or may not have to use trig in order to find that measurement. So when I'm saying trig, I mean like we're talking SOHCAHTOA, sine, cosine, and tangent. Or we could be talking something as simple as the Pythagorean theorem. All right, so in order to do this, you're first going to find the measure of the central angle, divide it by 2, so that way you can find that upper angle. Then you'll use trig with the angle and a piece of the other information given to find any missing parts, that missing part generally being your apothem, or it could be the side length in this case. And with all the parts, you then use your area formula. So keep these steps in mind for the next problems we have to tackle. All right, so let's start with this first problem. It says the side of a regular hexagon is 3 meters. I'm not going to draw the entire hexagon. A hexagon has 6 sides, in case you're curious. But let's just draw a central angle, or the triangle that will be created using the central angle. Well, if a hexagon has 6 sides, this central angle up top should have a measure of whatever 360 divided by 6 would be. Well, that's just going to be 60 degrees. And so then if we were to draw the apothem down this, we would want to cut 60 in half to figure out this angle here. Well, that'd be 30. So that upper angle has a measure of 30. We know that the side lengths are 3 meters. So that means this whole thing is 3, but I'm not worried about the whole thing right now. I only need part of it. So 1.5 and 1.5, because I'm actually looking for the missing apothem here. So to find the apothem, I'm going to use right triangle trig, because right now I have opposite and I'm looking for the adjacent. So that means I'm going to take the tangent of 30 over 1 equals 1.5 over a. And so when I cross multiply here, I get that the apothem has a length of 2.6. And so now that I know the apothem, I can use this to find the area. So area equals 1/2 the apothem times the perimeter. Well, the perimeter, it's a 6-sided shape that's 3 meters on every side. So 6 times 3 is 18. So I'm going to add that in my formula. And so when I multiply all of this out, I get the area for this shape to be 23.4 meters squared. Question 2 is done very similarly. The side of a regular nonagon. Nonagon has 9 sides. Every side is 10 centimeters. So I'm going to start by just focusing on one part of this, which would be the central angle. So if I take 360 divided by 9, I get that every central angle has a measure of 40 degrees. So that means when I draw the apothem in here, I'm splitting that angle in half. So this angle here is just 20. So I make my right angle here. I know that every length, the length of the sides is 10, so I'm worried about 5 and 5. And now I'm looking for my missing piece, which is my apothem. So right triangle trig says use the angle. I've got opposite and adjacent, so this would be tangent again. So the tangent of 20 over 1 equals 5 over a. I'll cross multiply, and I get the apothem in this case to be 13.74. So now that I know the apothem, I can find my area. Area equals 1/2 the apothem times the perimeter. Well, perimeter, it's 9 sides, every side is 10, so that would be a perimeter of 90. And then I'll multiply this out, and I get the perimeter for this shape, or sorry, the area for this shape to be 618.3 centimeters squared. This one's a little bit different. Very similar, but a little bit different. This time they tell us the radius of a regular octagon is 16.2 inches. So they're not giving us a side length, they're giving us a radius. So we'll see how this plays into the picture of our little triangle we draw here. So we still figure out the central angle. So an octagon is 8, which means every central angle, if we take 360 divided by 8, has a measure of 45 degrees. But instead of the 45, we're going to draw the apothem, and we're going to use half of that. So instead of 45, we'll take 22.5 degrees there. This time they gave us the radius, which would be this measurement here, in this case, the hypotenuse. So 16.2, but we're still looking for the apothem. So this measurement here. We're still going to use right triangle trig, but this time instead of opposite and adjacent, we have adjacent and hypotenuse. So now it's cosine of 22.5 over 1 equals A over 16.2. So we will go ahead and cross multiply here. And when we're done with solving this, we get that the apothem in this case is 14.97 inches. So that's helpful. But at that point, we realize we're missing something else. We also don't know the side length. Well, what we can do is we can find this half of the side length using trig as well. But to find that piece, we're going to have to use the sine, because this would be adjacent hypotenuse. So the sine of 22.5 over 1 equals x over 16.2. Same idea here, we cross multiply, and we get that the side length, or the piece of the side length there, is 6.2. So the entire side length is 12.4. So now we can find our area for this shape. Area equals 1/2 the apothem times the perimeter. Well, the perimeter would be the side length of 12.4 times the number of sides, which would be 8 in this case, because it's an octagon. So when we multiply all of that out, we get our area is equal to 742.5 inches squared. Question 4 is done very similarly. We have, in this case, a radius again. So we'll draw our triangle. They tell us the radius is 6 feet, but we need to figure out what the central angle would be. So it's a hexagon, so 360 divided by 6 gives us a central angle of 60. So that means this half of an angle here would be 30. We need, in this case, to find not only the apothem, but the side length, or part of the side length in this case. So we're going to use trig again. So for the apothem, we'd be using cosine. For the side, we'd be using sine. So cosine of 30 over 1 equals A over 6. And then we've got sine of 30 equals X over 6. Our apothem for this particular problem should come out to be 5.2, oops, the apothem is 5.2, where the side length in this case, or this portion of the side length, is going to be 3, so the entire side length is 6. So now we set up our area formula. Area equals 1/2 the apothem times the perimeter. Well, this would be 6 times 6, because it's 6-sided shape, side length of 6. And our area in this case is going to be 93.6 feet squared. All right, question 5. This time they tell us the perimeter. They say the perimeter of the 15-sided shape is 90 meters. Well, same approach we've taken so far. We just have to understand how to apply the information. Well, first we have a 15-sided shape. So to find the central angle, we'll take 360 divided by 15, which in this case gives us a central angle of 24. So half of 24 would be 12. So this angle here would be 12. They tell us that it's a 15-sided shape that has a perimeter of 90. So to find one side length, we'll divide 90 by 15. And we get that the side lengths are just 6. So that means we'd have 3 and 3. And we're looking for the apothem. So this is actually a lot like the first problems we looked at, because now we're back to using right triangle trig of opposite and adjacent. So this will be tangent of 12 over 1 equals 3 over a. We'll go ahead and cross multiply and then divide, at which point we should get our apothem to be equal to 14.1. And so now that we know what our apothem is, we can set up our area formula because they found the perimeter for us already. So we take 1/2 the apothem times the perimeter, which they told us was 90. And we'll go ahead and multiply all this out. And we should get that our area is 634.5 meters squared. All right, go ahead and try the 6th problem on your own. So pause the video, calculate all your answers, and then when you're ready to see the answers to the problem, unpause the video.